Hi, how are you?
I'm good. How are you?
All is well. First and foremost, I want to thank you so much for coming on the platform. This is really an honor.
Thank you for the invitation.
Definitely, definitely. We're gonna get right into it. For the viewers who may not recognize you, let them know who you are, where you're from, and definitely what you do.
My name is Judy. I work at Emory University. I'm a doctor, but my home is in Kenya in East Africa. So I'm a mini immigrant and live in Atlanta. And my time is spent taking care of patients, but also teaching and doing research around data science for healthcare.
Wow. Okay. Okay. That's cool. I'm currently in East Africa. I'm in Madagascar, but I have had the amazing opportunity to visit Kenya. It's definitely a beautiful country for sure.
Awesome.
Yeah, yeah. So I have to ask you, when did you develop this passion for science?
Yeah, I don't know that I can say the exact timing, but I would say that when I describe myself, I'd say that I love students and I love science. And the reason for those two things is I'm a very curious person. I like to ask questions and answer them. And, when I was sort of a little younger, my school didn't really, and actually overall medicine didn't really have an appreciation for people who liked science because it was considered that you are not a good doctor or you didn't want to take care of patients. And so I didn't, at some point in my life through medical school, I didn't have really big role models for science, but I find myself very, very curious just around my life. And I'm always asking questions and answering them. So now it's more sort of structured, but I cannot tell you the transition. But I enjoy just being in research, asking questions, finding answers, and also training and just seeing like the light bulbs light up for many young people.
Okay, okay, that's really cool. Now I can ask you for the viewers who may not know, what exactly is radiology?
Yeah. So um, before the TikToks and the Instagrams were famous, people could still take pictures of your body, and that's what radiology is. So we have these special cameras that can use X-rays or can use the water system or ultrasound to take pictures of various parts of your body. So I think unless if you've been sick, you've interacted with some form of radiology, whether you got a chest X-ray or a CT scan. And now, if you have a lot of resources, I think people are trying to make these whole body studies to try and tell them if they're sick or they have cancer. So there's quite a lot of revolution, but it's really taking pictures of the body. Now, there are many types of radiologists. They are usually localized by the part of the body part that people specialize in. For example, if you like to read things are of the head, for example, Alzheimer's disease or any dementias or stroke, or if you've had an accident and you want to interpret those studies, then that's called a neuroradiologist. I'm an interventional radiologist, which means that we use these smart cameras to do procedures and do intervention. So do minimally invasive surgery.
Wow, that sounds amazing. Um, okay, now I wanted to ask you about this. Now, you're a professor at Emory. What courses do you teach exactly?
So I am a different type of professor because in the medical school you teach one-on-one, right? So I'm teaching the next doctors. So I just pretty much teach interventional radiology. For the non-medical students, I do offer them. I do also for the medical school. I teach about artificial intelligence for 1 month for all the students. They can opt to take that class, and then I also provide a research rotation, which students from any of the schools can come and do research with me.
Ah, okay, okay. Um, Now I wanted to ask you about the research. Okay, you do research for Stanford and with the artificial intelligence. Is that something? Is that what you were talking about, or is that something separate and different?
And I don't do it for Stanford. I think the Stanford part is just because we are affiliated with the Amy Center. Um, I do research here at Emory on artificial intelligence.
Ah, okay, okay, I got you. Now, in terms of artificial intelligence, is this something that you're just getting into, or is this something that you've been interested in for a long time? Because it seems like more people are talking about it now, you know.
Yeah, now most of the researchers have been made over the last years because the capability of artificial intelligence wasn't there, till the success of the ImageNet algorithms. My I am sort of, I've always been very interested in how technology is used for healthcare. So even if today our group is known mainly for artificial intelligence, it's not because that's sort of like where we set out to be initially. And the reason is I'm very fascinated with technology. One, because earlier on I was very optimistic that it improves patients' lives and saves lives, but that's not the case actually. It's very, very difficult to say that without this computer or without this software, I would not have saved a patient's life. But the way people interact with technology is really interesting. And I think right now there's a lot of public discourse around this. So, for example, with education, where we're seeing many people are saying, like with the large language models like GPT, that you can have a personal tutor who never gets tired, right? If you see most of the sentiment around education, it's been that people are saying, oh, the teachers are overwhelmed, we can bring technology. But if you look at the evidence for all those technologies, it's not really made an impact. It's actually more disruptive more than just the hands, the one-on-one interaction for teachers. So, we started off, my foray into this was around 2008, which also was a big time around then, because that's when, if anyone has been following the AI world, then you'll know that there were big successes because of this data set called ImageNet, which was a big data set, and people showed that using computers we could beat the benchmark of what was the best performance for classifying the objects that are in that data set. And this just means like saying this is a dog or a cat or something else. And then something else was also happening around those early times, which is that people loved and were obsessed about uh, cats and dogs. And to be able to label those videos for people to enjoy them, then it was impossible to use humans based on how fast people uploading videos to, for example, YouTube, to label those data sets, because it was just impossible. And so based on that, there had to be a way of trying to classify what those videos are, and so that they are tagged, and so that people who like to watch cats and dogs on YouTube could be able to see that. And so with those big successes, right, there was a business need, and clearly were a task that humans were not going to be able to scale. There was Geoff Hinton, who got the Nobel Prize this year, was saying, look, we can do the same for radiology, we can do the same for medicine, we can we don't need radiologists. And he is quoted saying that in 5 years, it's not going to require radiologists. And, if you're a medical student, you have a lot of debt, you're trying to figure out what career do you want. When you hear this, people are not going to go to medical school, right? And people are not going to specialize in radiology. And that's what started happening. So my role then was to organize these meetings that would take place around 8 p.m. And I would sort of lean on my computer science connections and invite people and bring the doctors, and we would start discussing like what was the real gains made in this technology and how would it affect radiology. So that was my foray into sort of getting into AI, learning more about AI, applying it in my work, and doing a lot of outreach to sort of demystify what AI was going to do for radiologists.
Oh, okay. That's really interesting because, like, you see the smart cars, or you see places where the AI is replacing the workers. So it seems like across the board, people have somewhat of a fear of AI, even though it's growing and it's being used. And then I could ask you in comparison to say, like, we have music now. Like, say um, you could make a song using Tupac's voice, but obviously he passed away. He's not around anymore. Or you can make a movie using a actor's image without them being there or without them being alive. How can AI How is it, used specifically for radiology?
Mhm. So, number one is in radiology, because they're pictures, right? We have sort of three things, although now there's more things you can do that you can do with radiology. You can, number one, classify. So you're just saying, the same way you say this is a cat or a dog, you're essentially saying this is pneumonia or no pneumonia, or this is cancer, no cancer, right? So something similar. The second place that you can do is say, I'm going to draw around the abnormality, and it's really the same. I think the public and even the doctors think that it's different type of images. Yes, it's different type of images, but it's the same type of task. So if you've watched automation algorithm for cars, then you'll see that the cars on the road, right? You can see a box around a car or something like that. So those are called detection tasks. And then we have segmentation, where you're really drawing the contour, let's say, of the heel and everything else. So it's the same for radiology. So you can say, I want to say whether there's cancer or no cancer, but at the same time, the cancer could be, I could just give you a percentage of the likelihood of cancer, or I could say, here's the cancer that I think, by drawing a box around it, or I can segment the tumor where I draw exactly, the circle that I think is the tumor. So that's one big way that, for diagnosis, that radiology AI is used. Now, there is a lot of work being done around the collateral work that is necessary for to be a radiologist. For example, patients need to be able to access their reports. They need to be able to access them in a way that they understand, or be able to ask questions that they may feel embarrassed or may not have time to ask their doctors. And so we're seeing a lot of the large language models applied to the radiology report, so that you have an interactive way of doing that. And you can, as you know, that you can translate some of these languages and text, so that you can use them in the way that you're comfortable with. The other areas we're seeing is that you can merge multiple data sets. So that's going to be probably one of the bigger frontiers of multimodal data, where you merge, for example, pathology and radiology data sets, or some other thing, to give you a better insight of the patient. So radiology is leading in terms of AI development and FDA approvals. I think now there are over 1,000 products. Most of them are radiology, but the ones that are actually used in the clinical system are very few, because it's not just the technology. I think the technology gets there, but the support that is necessary to be able to run and make sure that it's helpful, is it valuable, is it making a difference, it's not too disruptive. I think that's sort of where radiology is. But I want to say that overall, when I've interacted with other sort of medical specialties like medicine and oncology, radiology is years ahead of sort of that learning curve, and really figuring out what system should we build or not.
Okay, I appreciate you breaking that down. That makes a lot of sense. Now I can ask you if you could speak about evaluating AI for bias and fairness.
So that's an unlikely path that I thought I would take, but um, we we were investigating, in research. Sometimes you just are looking for questions, but we were. This was around the COVID, right? So a lot of social injustice issues came up a lot and became forefront of everyone, through COVID, and sort of like the police brutality. And so around that time, what we did was say, one of our journals called for an article that was going to say, hey, let's show us work that can show health equity, right? Because everyone was shocked, right, that only some patients were really dying from, COVID in big numbers. And some of those things had factors to do with sort of the type of jobs people have, right? So the what we ended up sort of proposing to do, and this was rejected, was to say, look, we need to have more diverse data sets. And that's been sort of like the big thought. We need more diverse data sets to narrow sort of like disparities. And this took us down a rabbit hole, and which ended up with a surprising finding that most people have done different versions of it, that if I got your chest x-ray, that picture of you, right, it doesn't have black or white or Asian or different colors. It's just a gray image. But I could tell you or you're black or you're white. And I like to say it to make sure that it's even more ridiculous, by saying, for example, it could tell you that you're American and I'm Kenyan, something like that, right? That's sort of like a social thing. There's no biology thing that makes me, Kenyan and you something else, So I so we started showing that these models have hidden signals. They're able to encode a lot of information, and we brought this to sort of like an area for people to explore. And it started to make me think, how do we think about bias? Now, I'll tell you that I've learned quite a lot over the last 6 years. And the one thing is that we cannot agree what a fair model is, and that makes it very challenging to think about evaluating AI for bias. And the second thing is that you can have a biased model with a health equity lens. So just a fair model does not always, is not always synonymous to health equity. So, for example, several people may say, let's give more resources, right? But it's not, it may be that the more resources, like to get you to the hospital, is not what's the limiting barrier for you to come to the hospital. It's the hours, because that's what your job dictates, right? So it doesn't matter what you do, you're taking away from someone else who could use the time slot in the healthcare system, and I'm not going to come because I have to have a job, And so it's this sort of complexity of translating what fair models are. I think today what we can agree on is that there has been historical injustices in how people are cared for. I know that even from my own experience. We know that Black moms die at a disproportionately big rate, even when they have a lot of income and a lot of education, as we've seen the stories of Serena Williams and Beyonce, during birth, right? And so those type of things, with how we train AI today, can really, really amplify the bias patterns, because they're unconscious biases. No doctor goes into work saying, oh, I'm going to be, racist today, or I'm going to be, not taking care of this subgroup of patients better or not. But the way we care for patients is encoded. And now, because AI allows us to look at these big data sets, we can really, if we're not careful in how we audit and how we evaluate, then it can really perpetuate disparities. And we see these examples, for example, with lab tests. In the US, most of the labs, if you've been unfortunate to be in the hospital, you'll realize that these come, like, they are collected around, someone will wake you up around 3 to 5 a.m. And this is because by the time the doctors round around 7, right, those lab results need to be ready so that they can make a decision. So if you looked at just not giving me the lab value, but you told me this is when the blood sample was collected, I can tell you if that's going to be abnormal or normal, even without giving me the lab value. Because if you find someone who's getting a lab value at 11 or 3, just an odd time, then it's most likely going to be abnormal because it's off the cycle. So for us humans, we may not really think about that type of sort of correlation, but the AI model is not really learning the disease, it's learning the pattern, and that's the pattern that it sees. And so that's why, thinking about unpacking bias is really difficult, and evaluating without a unifiable definition, and also this challenge of encoded hidden signals, like what I said about nationalities or race, which are social constructs that can still be encoded by the models, and then having a limited granularity of the data that allows us to ask this type of questions, because it's not like you're always thinking, oh, I should investigate this, right? It's just because you happen to land on a finding that you cannot explain, but when you have the data set, you can go back and say, why is this failing?
Oh, okay. Wow. I really take my hat off to you, doing some amazing work, and it's definitely appreciated. I wanted to ask you about something. You kind of touched on it earlier about mentoring students. From your profile, it said you mentored about 60 students from all over the world. I just want to know, where are some of the places that your students come from, and what is that experience like?
Yeah, so I'm a last man student. I grew up in the village. I've been very, very very, very lucky because a lot of people allowed me to ride on their shoulders. I find that I'm very fascinated about how people learn. My own learning style is very it has to be very simple. And I learn from a problem-based type of learning. So I like to learn from a problem and then explore it. And so I find myself thinking, what are the basic skills that are necessary to do that? And I'll tell you, around 2 years ago, I got a gift. My Christmas present was a piano. And I thought, I'm a really good learner from YouTube. And I started watching YouTube to learn the piano. And I can tell you, I did not learn. It required a human being, a teacher, to help me learn. And I like to give this example because you have to have enough motivation to learn something. And then two, you have to be in a place where you can be able to sort of like it's easy to learn with others, right? And you also need to understand what's the basic fundamental that is necessary for you to gain another skill. So, for example, if all the YouTube videos are in English and I don't understand English, then it will be difficult to learn anything else that way. And so I find that the students who succeed with me are the ones who have a lot of self-drive. I don't mind that they don't know any technical skills or information, because it turns out that you can pretty much teach those, especially in the group, and that they are just people who push the limits and they're not afraid to. Our lab, though, has a very low hierarchy, so you can correct me or bring something new or do something different, And I find that those are the students that tend to be very successful with me. And so I've had students right now. I have a PhD student at MD Anderson, and I have students from MIT. I've had students from I've had students from Stanford. Pretty much, I've been on either a committee or working with a student from somewhere. Columbia now, I have a PhD student there, and Emory, Georgia Tech University, and some from Indiana. I have another PhD student who's there. And I find that what's been successful for me is this concept of village mentoring, that you're not an expert. You bring the people who need to be in the room to learn, and then you try to figure out what's that recipe to learn. And if you're a good match, because I've also fired myself from being someone's mentor when we are not a good fit. And the students should feel empowered to do so.
Okay. Let me see. I got about one or two more questions. Would you be able to speak about the initiative to harness data science for health in Africa?
Yeah. So, one of the things that we've always done is I got involved in this group where it's called the MIT Critical Data Team, and we usually have always tried to build capacity for people to have their own students and bring doctors, scientists, just different people together to ask questions of the data. So actually every year I host a datathon here in Emory, where we do the same, and we bring new students, we bring people, we do a lot of outreach for people to come and just work with data and ask questions that they think are more important for their patients. And so in this sort of network, we started doing this. And so for 2 years, I was loaned to the NIH to help, just to provide expertise in sort of doing data science for health in Africa. So this is a project funded by the National Institute of Health. And it's really interesting because it really looks at education, looks at research, looks at ethics and social issues around data science, and then doesn't just look at data science from one lens. It looks at data science from multiple lenses. For example, thinking about antimicrobial resistance, thinking about climate change, thinking about traffic accidents, thinking about genomics, and thinking about medical imaging. And then starts to say, how can we build capacity, build people who learn how to use these data sets and can scale the skills, and how do we build networks where people can learn together. So that's the program, and it's been going on. I worked there for partially for 2 years, trying to build sort of these community patterns for learning and facilitating them to build their datathons again. And I feel that it's sort of just trying to say, look, we need to think about data. And I want to caution that we're not saying AI, because that's just one way of analyzing data, but looking at data and what can it tell us and around health for many places of Africa.
Oh, okay. Wow. I'm really interested in that. I'd love to see how that goes. I guess my last question is, you covered a lot of very, very interesting topics. Have you ever considered writing a book or doing a documentary about your work or your research?
Not yet. Yeah.
Okay, okay.
Mhm.
Well, I want to thank you so much for stopping by. I really appreciate you taking out the time to share, like I said, the amazing work that you are doing. And I definitely look forward to the work that you have to come in the future.
Thank you so much.
All right.
Okay.
Take care.
Bye.